Okie dokie, here we are. Okay, I got to record today. I got to record this hour. Okay, so here we go. So our objective is to add, subtract, multiply, and divide these. We're picking up from yesterday. Okay, so add, subtract, multiply, and divide. And as you notice, we began with two polynomials yesterday, and then we worked with two radical expressions. So here we are going to move on to rational expressions, meaning that they are fractions. So I have f plus g of x. So I'm going to add those two together. Are you allowed to add those two together? In order to add fractions, you must have common denominators. Are the denominators the same? They are. And because the denominators are the same, we can then add them. So we are just going to have 4 plus 2x over x minus 1. Not too bad, huh? You good? Okay. Now let's do f minus g of x. Can we subtract fractions? Just have to have common denominators, which we have. So it'll be 4 minus 2x over x minus 1. Can we multiply fractions? How do we multiply fractions again? Say you have 3/8 times 2/5. How do you multiply those? Yep, just straight across, right? We get 6 over 40, and then you could reduce. Each one is divisible by 2, so 3 over 20. Okay? So if we have f times g of x, we have 4 times 2x is 8x over x minus 1. Can we divide fractions? Yep. So f divided by g of x is going to be 4 over x minus 1 divided by 2x over x minus 1. Do I leave? Yes. Oh, yes. Thank you. Sorry, people watching the video. As you multiply the denominators as well, you do get that x minus 1 quantity squared. So for all those, you're like, he made a mistake. Yes, I did. Which was funny because I was thinking about it before I did the problem, and then when I was doing the problem, I forgot. Okay, so can I leave my division like that? Why? What is that called when it sits in that form? Starts with a C. Complex fraction. Can't leave complex fractions, meaning fraction within a fraction. There's actually 3 fractions here, right? You got the fraction at the top, the fraction at the bottom, and then the entire thing is a fraction as well. So we need to reduce it to 1 fraction. What do I do to reduce that to 1 fraction? Yeah, you multiply it by the reciprocal. So you multiply by x minus 1 over 2x. And what's going to happen when you multiply those? Yeah, the x minus 1s are going to cancel because those divide and make 1, and we get 4 over 2x. Is that simplified? No, it's not. I could divide the top and bottom by 2, and I get 2 over x, so that would be my result. So again, yesterday we just wanted to see, do you know how to deal with polynomials? Do you know how to deal with radicals? And do you know how to deal with fractions? Okay. I think the radicals were probably kind of the ones that were toughest, huh? Here, the rational expression, not too bad, was it? Okay. Any question on that before we do a domain? Okay, let's go to domain then. The domain, remember, is going to be the domain of f intersect the domain of g. So we're looking at the overlap of the two domains. So as I look at the domain of f, okay, the domain of f, what number can you not plug in for x? 1. Why can you not plug in 1? Produces 0, and we get 0 in the denominator, and you can't divide by 0. So very good. X cannot be equal to 1 is the domain for f. How about the domain for g? X can't be 1. So what's the overlap between x can't be 1 and x can't be 1? X can't be 1. So, therefore, the domain for the addition of the two will be x cannot be equal to 1. Do you remember if that's the same for subtraction? It is. X cannot be 1. Is it the same for multiplication? It is. X cannot be 1. Is it the same for division? No, it's not. Okay, we also have to consider where the denominator would be equal to 0. And here's what I want to point to an important aspect to you. And I'm going to go back to our original setup here. Okay, so this is the one thing you have to be aware of if you were dividing fractions. So we have 4 over x minus 1. Okay, and I want you to focus on what it looks like before we simplify it. I don't want you to focus on the 2 over x right now. I want you to focus on this guy. Okay, notice we have how many fractions here? 3 fractions, right? Now we have this denominator and this denominator, right? So what would produce 0 in that denominator? 1. So we know x can't be 1, agreed? X can't be 1. But we also have another denominator. Isn't this thing right here a denominator for that top fraction? So what would produce 0 for this denominator? 0. Do you see that? Okay. So x cannot be 1 or 0. Because if you had 2 times 0, this whole expression right here would be 0, and you'd be dividing by 0, and that doesn't work, right? Now, if you just looked at the end result right here, you would say, well, x can't be 0. So you see that you end up catching the 0 there if you look at the end one, right? But you don't pick up the 1, do you? That got lost in the shuffle. It canceled out. So make sure you look at the fraction before you simplify it. We all good? All right, yes. Yeah, if 1 went in for each x, we would have 4 over 0 divided by 2 times 1 is 2 over, you would get 0, right? And notice how you have 0 and 2 denominators. That's a problem, isn't it? But if you were to plug in 0 as well, let's see what happens if you plug in 0. You would get 4 over negative 1. Well, that's okay, isn't it? Divided by 0 over negative 1. Well, notice that is 0, and you're dividing by 0 then. So both of those are problems.
So I know why 1 is, but why do we get 0?
Let's just look at the end one right there. 2 divided by x. What number would x be that would produce 0 in the denominator? 0. Nope. You gotta look at this one and what happened before you simplified it. That's the key to telling you which one it's going to be. Let's follow up with an example on your homework and see if we can understand that one. Okay. All right. Okay. Flip it over the last piece, and you're going to have a significant amount of time to work today. So that's kind of the first part of the lesson of adding and subtracting and multiplying and dividing functions and performing those operations. The fact is we really don't use it that much. You might see something come up on the ACT exam that would incorporate that, but without a doubt, this is the really important stuff, okay? And this is what you're going to see when you get to your test especially. And this is what we use moving forward. We want to be able to look at these functions and determine the domain. Now, if you look at this right here, f of x is the square root of 2 minus x plus 1, okay? Did we learn how to graph that in the last unit? We learned how to graph parts of it, right? Like we learned how to graph the square root of 2 minus x, right? We learned how to graph x plus 1, but we didn't learn how to graph the whole thing together, right? We didn't. And we didn't learn how to graph something that looked like example C, did we? And we didn't learn how to graph something that looks like example D. But we can still tell something important about it. We can determine the domain very simply by using what we used on the previous page. I'm going to say that this is the addition of 2 functions. It's function f, which is the square root of 2 minus x, plus the function g, which is x plus 1. So if I want to know this domain as a whole, I just figure out what's the domain of G and what's the domain of F, and then I consider the overlap between them. So what's the domain of x plus 1? What shape does that make? Makes a line. And what's the domain of a line? All real numbers. That was nice and easy, okay? So we know that one's all real numbers. But is the domain of a square root function all real numbers? It is not. So how do I determine the domain of that? What do I set up? Yep, 2 minus x is greater than or equal to 0. So now as I solve, I subtract 2. And I get negative x is greater than or equal to negative 2. Divide by negative 1, x is less than or equal to 2. So once again, if I, just to make sure everybody understands, I know people watching this video, suppose I had a number line, all real numbers looks like the blue. And then x less than or equal to 2, well, that looks like this. And so what's the overlap? Well, x less than or equal to 2, or negative infinity to positive 2. A lot of people don't know what that looks like when you graph it. Okay, we haven't talked about making that graph before. But I'm going to say that this is two functions multiplied together. Function f, which will be x cubed, times function g, which will be 1 minus x. What's the domain of a cubic? All real numbers. What's the domain of 1 minus x? All real numbers. What's the overlap between all real numbers and all real numbers? So negative infinity to positive infinity. Anything you plug in for x will produce an output for y. That's what that's saying. Yes? So we're really going to divide these into 3 categories. We have 3 types of functions. We have polynomials, we have radicals, and we have rational expressions. And if we get a polynomial, and that's just like say x plus 5, that's a polynomial. X to the third minus 3x, that's a polynomial. X to the fifth plus 6x squared plus 2x minus 1, that's a polynomial. Meaning it's many terms just added together that have powers on them. Okay, these are all polynomials. They are all real numbers. You plug something in, you get something out. If you have a radical, such as the square root of x plus 3, well, that's a problem. We have to set up x plus 3 greater than or equal to 0. Do we have to restrict the domain of a cubed root? Nope, that one's all real numbers. You could take the cubed root of a negative number, so you're okay there. Rational functions, say 1 over x minus 3, we would say x cannot be 3, right? So in your brain, when you're thinking about domain, you should be dividing them into 3 categories. These are the 3 categories that we consider. Okay, somebody's taking my picture right now. There we go. Not mine. No. We good? Okay, so there we go. So we got all real numbers because that's a polynomial, all real numbers because that's a polynomial. We move along, okay? Let's look at the domain of the top one. I have no idea what that function looks like. Like, I'm pretty good at math, but if you ask me to graph it right now, I wouldn't know what to do. But I can still tell something important about it. What's the domain of a cube root function? All real numbers. What's the domain of a x squared minus 9? All real numbers. Except when you're dividing 2 functions, you have to say I can't divide by 0. So what numbers would produce 0 in the denominator? 3 and negative 3. Because x squared minus 9 factors to x plus 3 and x minus 3. So remember our work, we said you look at the overlap, and the overlap is all real numbers, but you also can't divide by 0. And so x cannot be negative 3 or positive 3. Don't know what that looks like. I have no idea. But I do know how to find the domain of a cube root function. What's the domain of a cube root function? All real numbers? Is the domain of a fourth root function all real numbers? It is not. You can't take the fourth root of a negative. So what do you set up? Good. 2x minus 7 is greater than or equal to 0. So the first one, it's all real numbers. The second one is 2x minus 7 is greater or equal to 0. 2x greater than or equal to 7. So x greater than or equal to 7 halves. If you want to list it as a decimal, that's fine. 3.5. So we are going to go 7 halves to infinity. Two more, and then we call it quits for today. Here I'm dividing. What's the domain of x squared? All real numbers. What's the domain of x cubed plus 1? All real numbers. But because I have a fraction, I can't divide by 0. So where would x cubed plus 1 be equal to 0? Yep, x cannot be negative 1. Now, did you guys, how did you figure that out? Just think about it or what? Did anybody factor it? I'm just going to write it out so that you see. That's kind of why I put it there. If you remember, the sum of cubes factors to x plus 1. And do people remember how the next part goes? X squared, good, square the front. Square the back, multiply the two together, this sign's opposite. If you ever factor the sum and difference of cubes, I should say 95% of the time, this will not have any real solutions. They'll all be imaginary. You really only need to be concerned about this one. And as you can see, negative 1 is what would produce 0 there. So x cannot be negative 1. Okay. The other way is just say x cubed plus 1 equal to 0. Just subtract the 1. X cubed equal to negative 1. And then cube root both sides, and you'll get negative 1. So you're fine there too. Okay, last one. Again, I'm going to say this is like function f times function g. So I say it's two functions. I'm going to look at them separately, determine the domain of each of them. So what's the domain of 4 minus x to the 5th? All real numbers, because that's a polynomial. If you're to multiply it out 5 times, you just get this big long polynomial, right? Is the domain of the square root of 3 minus x, is that all real numbers? No. 3 minus x must be greater than or equal to 0. Negative x is greater than or equal to negative 3. X is less than or equal to 3. So I've got negative infinity to 3. And obviously the overlap between all real numbers and negative infinity to 3 is negative infinity to 3. I would appreciate it if you quick paired and shared right now with those around you. Think about, we just talked about domain now, and we talked about domain on the last test. Do you understand it better, worse, or the same? Talk with those. Go. Okay, I see Caden putting his thumb up. And you understand it better? Why? What makes more sense? Is there a part that stood out to you more than another? Okay, it seems simpler. Can I tell you guys a secret? You understand something better when you learn it multiple times, don't you? So without a doubt, I've tried to build certain things in to help us out, to kind of go back and spiral and look at it a little bit better. So you understand it better when you cycle through multiple times. And so it's okay to go back and review some of those things. So if you're really looking to try to improve in some way in class, so every once in a while, maybe just like you might be working on this assignment today, but maybe you go back during study hall and you pick a problem on your first or second assignment, you try that one again. For example, right now, do you guys think that you could place a parabola into vertex form if it was x squared minus 10x plus 1? We did a checkpoint on that yesterday, didn't we? Think you could do it? You probably could, but we did a checkpoint on it, didn't we? What didn't we do a checkpoint on? We said, well, suppose you had to take this and it's in standard form and find the vertex by doing negative b divided by 2a and then plugging that in. That might be something like, well, we need to do a checkpoint. I don't remember it as well. Okay, so it's okay to go back and review some of those things. You guys have the rest of the hour to work. You can now finish off combining functions. I'll post the answer key online.